opened quizzes 1 to 3 in the lecture and quizzes 1 to 4 in the laboratory. In-extend ko yung availability niya until March 16, 11:59 p.m. Okay, that is to accommodate those who were unable to take it, either due to health concerns or o kaya dun sa mga currently affected by weather disturbances lately. Okay? So, yun lang. Wala namang issue sa akin yan. So, ayun. So, for our session today, sa lecture class ko, nag-start na kami na to. So, again, the topic is parallel. Okay? Sa lecture and lab. Nagkaiba lang sa dulo. Right? So, the first part of this discussion will be similar with what we will be discussed in the lecture if you have not taken one yet. Okay? So, parehas na parehas lang. Okay? So, to be more specific, these are the topics that are similar with the lecture. Ito yon, yung first three topics. However, itong part na to, ito yung bago. Okay? So, yun. Let's begin na siguro, no? So, let's have an overview again of the titration. And then, let's take into consideration kung paano natin ina-apply yung equations na ginagamit last time in determining the pH of the solution. Okay? Kasi yung titration nung nakaraan in the lecture, that is just more on, what do you call this? The endpoint determination. Na? So yung asynchronous discussion ng chapter 4, puro endpoint determination lang siya. At this chapter, what we aim is for us to know the pH of the titration process. Na? Ganun kasi talaga dapat kapag titration. Inaalam natin yung pH. Okay? Yan. So, let's take a look into that and how we will apply the previous knowledge, in different topics discussed previously in the lecture and the laboratory. And let's see how we will synthesize all those ideas. So, just an overview. Okay, so titration is a volumetric analysis. So when you say volumetric analysis, it makes use of liquids. So may mga liquid tayo. And not only that, we also use volumetric apparatus. When you say volumetric apparatus, these are apparatus that have graduations, no? So sila may mga markings dito sa ayan. For example, this one is a burette. It has some graduation or may mga markings sila. Okay? And that will actually help you to know the volume of liquid dispensed by the apparatus. So, syempre, this is your burette. Pag binuksan mo yung stopcock, the liquid will drip here, no? So, magdidrip siya dyan. And then, depending on the changes in the volume here, pwede mo malaman how much was transferred into your Erlenmeyer flask. Okay? So, yan yung volumetric analysis. We make use of liquids and apparatus that has graduations. Okay? Yan. And for the sake of simplicity of this course, we will just talk about neutralization titrations. Okay? There are so many types of titration, but ito yung pinakamadali, neutralization titration. Okay? So, in neutralization titration, if you can still recall, here we add acids and bases. So, our titrant and analyte could either be one of them. Okay? And then when they react, what happens? They combine to form salt and water. Okay? So, yun. Also, in titration, we know that we add our titrant. Okay? Titrant is the substance with known concentration. So, nilalagay natin siya to your analyte. Titrant nilalagay sa analyte. Nasaan uli yung titrant? Nasa burette. Tapos, ang ating analyte nasa Erlenmeyer flask. Okay? So, ina-add natin siya by increments of whatever ml you want. Pwede droplets. So, papatak-patak siya doon until you see color change. No? And that change in color is usually possible with the help of chemical indicators. No? For example, in this picture here, we have this phenolphthalein. Okay, this is phenolphthalein, and it turns pink if that reaction is complete. Okay, or if the pH is around 7. So, dun siya nagiging pink. Okay, so yan. Marami pang indicators na ginagamit, just as discussed in your lecture. Marami pa yon. So, not only phenolphthalein, we also have bromocresol green, methyl orange, etc. Okay, so anyway, we'll learn more about them in the next part of this discussion siguro. No? Siguro sa April ba yan. Okay, and then let's have some overview lang muna with the keywords na kailangan isapuso. Of course, your analyte is the substance that you don't know. Yun yung ina-analyze mo. Kaya nga tawag sa kanya analyte, ina-analyze siya. Okay? Siya yung inaalam mo. And then the titrant is the substance with known concentration. Okay? So yung analyte, hindi mo alam yung concentration. Pwede rin hindi mo alam yung identity niya. Pero yung titrant, alam mo siya. Okay? So kilala mo siya and you know the concentration. And again, yung titrant and yung analyte pinaghahalo para magkaroon ng reaction. Indicators. Pag sinabi natin indicators, these are chemicals that produces color at certain pH. No? And they often indicate the end of the reaction. Okay? So, kunwari, nag-pink na yung phenolphthalein, ibig sabihin nun, tapos na yung titration mo. Okay? So, you can do your calculations now. Equivalence point is the point at which the reaction is complete, and it can be determined by stoichiometry. Okay? And then, yung ating endpoint naman, this is an estimate of your equivalence point. Usually, dito nangyayari yung change in color sa endpoint. Okay? So, it is just an estimate of the, it is an estimate of the equivalence point. Okay? So, yan. Kasi equivalence point, yan kinakalculate yan yung endpoint, yun yung na-observe natin. Yun lang yung difference nila. And also in the lecture, probably you watch this video. Okay, this is just a video showing how to do titration and how to clean, set up, and use the apparatus. Sayang lang, no? Kasi hindi tayo face-to-face. Because kung face-to-face to, ang saya-saya ng experiment dito. Naka-stress din. Anyway, so hopefully by next academic year, face-to-face na. Because the government just allowed 100% of classroom to be used. No? So let's hope for the best. Pero not to be complacent. Kailangan hindi masyadong confident. Still, consider health protocols pa rin. Anyway, so I will not watch this video again in its entirety kasi nakwentuhan na yun sa ating lecture. Okay, and also, dito na tayo sa important part of the discussion. Okay, so ano to? We already know how to do titration calculations in chapter 4 of the lecture, diba? Pero yung calculation na yun, basic pa yun eh. Okay? So kung nahirapan kayo dun, may mas malala pa dun. Pero kung nadalian naman kayo dun, edi good, no? Kasi magagamit nyo talaga siya dito. Okay? Kasi in the previous chapter, what we were doing that time is we are getting the endpoint usually, di ba? Kung hindi endpoint, kinukuha natin yung molar mass of the analyte. No? So, yun yung ginagawa lang nun. Pero dito, in the titration calculation, iba. Okay? Kasi usually, you will be asked to determine the pH, no? Hindi yung endpoint mismo. Gagawin mo, maghahanap ka ng pH talaga, no? Okay? When you add your titrant, what will be the pH of the solution? Okay? How will it progress over time? So, yun yung ginagawa natin dito. Okay? So, in determining pH, we have to combine your knowledge of Chapter 4 sa lab. Okay? I-apply natin siya dito. Okay? In the previous chapter sa laboratory, I already introduced you to Henderson-Hasselbalch, right? So, si Henderson-Hasselbalch, it is an equation that is used when you have a buffer system. And that is important in this chapter as well. Kasi kapag nag-add ka ng chemicals, pwedeng magkaroon ka ng acid conjugate base pair o kaya pwedeng may base conjugate acid pair. And if that happens, meron kang acid conjugate base pair or base conjugate acid pair, pag may ganun ka, ibig sabihin may buffer system ka. So, if you have a buffer system, then the equation to be used to determine the pH of the solution is the Henderson-Hasselbalch. What's the Henderson-Hasselbalch equation again? So that's pH equals pKa plus logarithm of the conjugate base over the acid. Its POH form can be written as POH equals pKb plus conjugate acid divided by the base. Okay. Dalawang versions yan, di ba? So, kailangan isa puso nyo siya because we will use that in this chapter. Okay? So, tandaan, if you see conjugate acid-base pair here, you have to use the Henderson-Hasselbalch equation. What else? When you add acid, the base decreases, no? Yung amount ng base nababawasan. And kapag nag-add ka naman ng base, yung amount ng acid nababawasan. Why? No? Kasi nagre-react sila. Okay? So when you add acid to your base, mababawasan yung dami nilang. No? Kasi both of them will be converted into their corresponding products. Okay? So yun, it is very important. No? Kaya mapapansin nyo in one of the question in the last chapter, may tanong doon na ano eh, 'di ba sa buffer, what will happen if I add acid, 'di ba? Ang sabi ko sa inyo doon sa video, sabi ko doon that kapag naglagay ka ng base, magbabago talaga yung amounts ng acids and bases mo. So important 'yon. Mas lalo nyo siyang magagamit sa topic na to. Okay? So, wag na wag kakalimutan niyo. Okay? Next one. When you add your analyte and your titrant, of course, magkaiba volume nila. And kapag in-add mo sila, ano nangyayari? Dumataas yung volume. And what happens when the volume of your solution increases? There is a dilution. Nagkakaroon tayo ng dilution. So, ibig sabihin, we have to account for that. No? Kailangan iisama natin sa ating mga calculation yung dilution then. Okay? And then lastly, knowledge of equilibrium calculations will be helpful in some problems. Okay? Especially if it involves equilibrium systems such as weak acids or weak bases. Okay? So, ganun ha. So, yan yung mga kailangan isa puso. And again, don't worry. You are not that much pressured naman to understand this agad. Kasi we will continue this on April pa. Okay? So, tutuloy natin ulit sa April. Pero at least for now, maumpisahan natin kahit paano. Okay? So, pag yan ay naisa puso na, then pwede na natin pahirapan ang ating sarili. Okay, so these are the equations that we will use in this topic. Of course, do not forget your stoichiometry. Okay, so when we say equivalence point, we can say that the moles of your titrant and analyte are equivalent. Okay? We can use this equation, yung ginagamit natin sa lecture chapter 4, yun din gagamitin natin. Okay? Itong SFT, ano yan, huwag nyo na lang pansinin yan. Hindi ko siya natanggal o nakaraan. Okay? Dilution calculations, of course, yun yung MIVI equals MFVF. And when we talk about equilibrium, sorry. Nandito yung answer. Okay. So, when we talk about equilibrium, hindi na tayo mag-ice table. Yeah, we can use ice table, pero I will give you the shortcuts kasi remember, kapag nag-quiz tayo, tapos nag-ice table kayo, ang tagal, di ba? So, tuturuan ko kayo ng shortcuts. Okay? So, yung tinuro ko na square root of tsaka, gagamitin natin siya. Okay? So, we will assume that the ratios are 1 to, that the ratio of the concentration and the K is greater than 1,000. Okay? For easier calculations. And of course, the buffer equation or the Henderson-Hasselbalch equation, isa puso, isa isip, kabisaduhin, o kaya gumawa ng kodigo, kayo bahala. Okay? So, those are the equation that we will use in this topic. Medyo marami. And gaya nga ng sabi ko sa nasa lecture class ko kanina, in this topic, you will see at least 20 equations. Ganong karami yung equation sa chapter na to. Okay? And ang question kasi doon is, alin gagamitin mong equation na? Kasi ang dami. So, I hope that as we go on later, mas makita nyo na yung use ng equations. Okay? So, sige. Let's begin. Doon sa sinabi ko na 20 mahigit na equation, it's a case-to-case basis, no, kung kailan sila gagamitin. Okay? Because in doing neutralization titration, iba-iba yan eh. You can have monoprotic, diprotic, triprotic, or polyprotic. Okay? So what does that mean? Yung protic nun means protons, no, or hydronium ions. Ilan yung H plus that are being transferred, okay, for the reaction to happen. For simplicity, we'll just talk about monoprotic titrations. Okay? So, for simplicity lang. When you say monoprotic titration, we refer to acid-base reaction wherein the amount of H plus produced is just 1. Okay? So, ibig sabihin, isa yung H plus na pinoproduce, isa din yung H plus na nire-reactan. Okay? So, yan. So, that's monoprotic titration. And there are actually 4 versions of it na. Okay, 3 lang yung nalagay ko kasi parehas lang yung dalawa dun. Okay, we can have the strong acid, strong base titration or the strong base, strong acid titration. Parehas lang yan. Halos. We abbreviate it as SA, SB. Pwede rin SB, SA. Pwede sila magkabaliktad. Okay. So we have a strong acid, strong base titration or strong base, strong acid titration. We have the weak acid, strong base, and the weak base, strong acid. Okay, so those are the 4 types of monoprotic titration. Bakit kaya walang weak acid, weak base? No? Yun yung tanong ko dati sa prof ko eh. Sabi ko, sir, ba't walang weak acid, weak base? Ang sagot pala kasi, pag pareho silang weak, hindi na sila magre-react. Okay. So, sa bagay, weak nga sila eh. Paano sila magre-react sa isa't isa? So, at least, kailangan may isang strong. Okay? So, yun. So, what do we have to consider when doing calculations in titration? So, bale, the first thing you have to know is whether your chemicals are strong or weak. Na-discuss natin sa chapter 4 yan. Ano yung mga strong acid, ano yung mga weak acid, ano yung strong base, ano yung mga weak base. So, kailangan gamitin natin sila. Okay? You don't need to remember yung nasa table sa laboratory last time, hindi yung kinakabisado, kundi sinasa puso. Okay. Tsaka you will be given a hint naman. If that is a weak acid or a weak base, usually the pKa or the pKb values will be given to you. Okay. So, ibibigay yung Ka, ibibigay yung Kb, ganun. So, huwag kayong masyadong matakot dun. Okay? Kapag wala namang binigay na Ka, Kb, probably it suggests na siya ay strong. Okay? Also, remember that when we are determining the amounts of chemicals na nagre-react using strong acid, strong base, nag-stoic lang tayo, di ba? However, for weak acids or weak bases, we do equilibrium, ga-stable tayo, or in shortcut, square root of tsaka. Okay? So, kailangan isa puso nyo yung mga ganong diniscuss noong previous chapter. And then, once you are able to classify your given, then pwede ka na pumunta sa mga equations. Okay? Kasi iba-iba yung equation kada version ng titration. Kaya sinabi ko, at least 20 equations yung makikita nyo in this PowerPoint. Kasi may set ng equation for this type of titration, may set of equation for this type of titration, etc. Okay? So, magkakaiba sila ng equation. So, kailangan hindi kayo magkamali sa pag-identify if it is a strong or a weak acid or a base. Okay. Also, it is also important na kailangan alam mo yung sino yung analyte, sino yung titrant, of course, na kung sino yung unang sinabi dito sa words natin, sila yung analyte, na. Okay, palitan ko yung kulay ng ink. So, yung unang sinabi, yun yung analyte, na. So, analyte. So, strong acid yung analyte dito. Yung sumunod ay titrant. Okay? So, analyte then titrant. Okay? So, pag SBSA, analyte mo yung strong base, titrant mo yung strong acid. Kapag WASB, analyte mo yung weak acid, titrant mo yung strong base. Kapag WBSA, analyte mo yung weak base, titrant mo yung strong acid. Okay? Kung sino yung nauna, siya yung analyte. Kung sino sumunod, siya yung titrant. Okay? And gaya nga ng sabi ko, each of them will have different equations. Okay? Ito yung gagawin natin ngayon. Okay? So, just to solve yung mga basic problems na yan. Okay? So, yun lang yung goal natin today. And again, you are not really that pressured to hindi naman kayo ipipressure na magets nyo agad siya. Kasi we will continue this on April. Ha? Okay. But at least you have an idea already. Okay, so let's do the first case. Mag-strong acid, strong base muna tayo. Again, kung sino yung unang sinabi, siya yung analyte. Asan ang aking mouse? Ayun, nandito pala. So, ito yung analyte natin. At ito yung ating titrant. Okay? So, yan. So, sino unang binanggit, siya yung analyte. Okay? So, yan. Strong acid, strong base. So, ibig sabihin, in doing calculations, wala na tayong square root of tsaka, no? Simple, simple stoic lang yung gagawin natin. In titration, okay, let me begin with the stages of titration muna. In titration, we actually have 4 stages, no? You have your initial, okay? You have your initial, you have your pre-equivalence, okay? Your pre-equivalence, your equivalence, and your post-equivalence. So, 4 yung stages natin. Initial, pre-equivalence, equivalence, post-equivalence. And then, if each of them have different versions of equation. Kaya nakakalito na. Okay. So, iba-iba yan. Okay, para hindi tayo lalo malito, let's clarify. What does it mean for you to be at the initial stage, the pre-equivalence stage, equivalence, and the post-equivalence stage? So, tignan natin ano ba yung pinagkaiba talaga nila. Okay? So, ganito. In the initial stage, you don't have any titrant added yet. Wala ka pang nilalagay na titrant. Okay? Ibig sabihin, whatever the pH of the analyte is, yun na yun. Okay? Whatever the concentration of your analyte is, yun na yung kanyang initial pH. Okay? Then, kapag pre-equivalence point, what does that mean? Nag-add ka na ng titrant. So, nagpatak-patak ka na ng titrant. Kaso, kulang. Okay? Kulang in a sense na not all of the acid will be converted into salt, into neutral products. Okay? So, ganun. So, yung initial, wala ka pang nilalagay na titrant. In the pre-equivalence point, you added titrant na. Pero not enough for the reaction to be complete. Okay? So, yun yung pre-equivalence. Ang equivalence naman, this is the point wherein you added just the right amount of titrant. Okay? Just the right amount of titrant, no? Kaya, ayun, nag-neutralize na yung substances natin. Okay? And then, yung post-equivalence naman, in a post-equivalence, you added excess amount of titrant. Okay? Kung baga, nasobrahan ka ng patak. Okay? So, yun yung 4 stages. Initial, pre-equivalence, equivalence, post-equivalence. Initial, no titrant yet. Pre-equivalence, may titrant pero not that much. Equivalence, just the right amount of titrant for the reaction to be complete. Post-equivalence, ito yung sumobra ka ng patak. Okay? And so, yan. So, each of those stages have different chemical species present. No? Siyempre, sa iba-ibang stage na yan, may mga reaction. So, nagbabago-bago yung chemicals that are found in your system. So, for example, in the initial stage, what you have is just the water and your acid. No? Bakit acid yung kasama? Kasi sabi nga natin, SASB titration to. So, analyte natin is yung strong acid. So, your HA here refers to the acid that is present in your solution. So, itong dalawa lang yung species na present doon na. Ayan. And then, pag naglagay ka na ng titrant, you will then proceed to what's called the pre-equivalence point. So, what will happen to your HA? When you add your titrant, ano uli mangyayari? Ano nangyayari kapag naglagay ako ng base sa acid? Dumadami ba sila lalo? Nababawasan? Ano uli sinabi ko about that? Nasa previous slide yan. When I add my base titrant, what will happen to my acid analyte? Anyone? Nasabi ko na rin to sa lecture kanina. Okay. Pag naglagay ako ng base, what will happen to the acid? Decrease. Okay. Mababawasan yung acid. Ayun, nakalagay na less eh. Less. Bakit siya nababawasan? Because it gets reacted with the titrant base, no? Nagre-react na kasi siya with the titrant. So, na-form din yung salt, no? Kaya may salt ka dyan. Okay? Yung salt, ito yung product of the neutralization reaction. Okay? So, yun. So, may water ka na, may acid ka pa rin, pero not that much. And then you have the salt. Okay? At equivalence point, what's in here? All of your acids are then converted into their corresponding salt na. Lahat sila na-react na to form the salt product. Okay? So, wala ka ng acid. Okay? And in the post-equivalence, edi nasobrahan ka naman ng titrant. So, may excess base ka na. And yung salt na. Nakalimutan ko i-type to. May salt ka pa rin. Okay? Pero sumobra nga lang yung base na dinagdag. Okay? So, ganun. So, for us to know the correct equation per stage in determining the pH, no, we have to know first, sino ba yung major contributor sa pH ng solution. Okay? Kailangan alam kasi natin yun kung sino yung major contributor sa pH ng solution. So, let's talk about the initial stage muna. Okay. So, between water and the acid, which of them do you think will contribute to the pH? Which will be more significant? Is it the water or is it the acid concentration? Sino kaya yung magde-determine ng pH? Si water or yung acid? What do you think? Sino sa dalawa yung magde-determine ng pH? Is it the water or yung acid? Any guess? Actually, may clue na dyan sa column dyan. So, it is the acid. Correct. So, the acid will actually determine the acidity or the pH of your solution. So, siya yung magdidikta kung ano yung pH ng solution. Okay? Yan. Ito pala, disclaimer. Kung kayo mag-advance reading sa textbook, parang ganito din naman yung discussion. Although, yung version ko ay very simplified. Okay? Kasi dun sa textbook may mga ice table pa nga dito, shortcut tayo. Okay? Para naman hindi kayo ma-stress sa buhay. Okay? Okay, so you're all correct. At the initial stage, the one that will predict the pH of the solution is the acid, not the water. So, the question is, how will you get the pH? You just get the negative log of your acid concentration. No? Sasabihin naman yung concentration ng yung acid. No? So, whatever the concentration of your acid is, yun yung amount ng H+. Yeah. Okay? Kunwari, 0.5 molar HCl. So, ibig sabihin yung H+, 0.5 molar na rin. That's simple lang. Okay? Yan, naantok pa ako. Okay? So, whatever the concentration of your acid is, yun yung amount ng H+. Then, you just need to get the negative log na lang. Okay? So, ganun. Now, let's talk about the pre-equivalence point. Okay? So, at pre-equivalence point, which of them do you think will contribute to the pH of the solution? Which of the three species will contribute to the pH of the solution? Is it the water? Is it the acid? Is it the salt? What do you think? So, dyan, ano kaya yung magko-contribute sa pH? Ano kaya sa tingin niyo? Sa tatlong yan, between water, acid, and salt, sino ang magko-contribute sa pH? Any guess? Yung acid pa rin. Okay. Acid pa rin. Okay. Ganun na. Huwag kayong masyadong ma-intimidate sa mga nangyayari. Basta tandaan nyo, yung acid pa rin yung magdidikta ng pH natin. Kaso tandaan nyo, yung acid natin nabawasan, di ba? So, nabawasan na yung dami ng acid. So, ang gagawin mo? So, dun sa initial concentration ng acid mo, ima-minus mo dun yung nag-react sa base. Okay? So, sa initial concentration ng acid, ima-minus mo yung nagamit panlaban sa base. Okay? So, that's why the equation looks like this. Okay? So, it's MAVA minus MTVT over V total. Okay? So, what do we get ba when we multiply molarity and volume? Ano yung nasosolve natin when we multiply molarity and volume? That is what? That is, when you multiply molarity and volume, ano nakukuha natin? Ang nakukuha natin ay molarity times volume. Ano yan? Ilang beses nyo na ginagawa yung calculations na yan. Molarity times volume gives you what? Molarity times volume will give you what's the answer? Moles, correct. Okay? So, molarity times volume will give you moles. Okay? So, yeah. So, ibig sabihin, just to explain this equation, so this is just the mole of your acid minus the mole of the base. No? Yeah. So, this is just the mole of your acid minus the mole of your base. And then we divide it by the total volume. Okay? So, bakit mole? Kasi, yung molarity, hindi mo siya masusubtract. Okay? Ano yun eh? Ibang yun eh. Ibang quantity yun eh. Kumbaga, parang density yan. Hindi mo pinagsusubtract yung dalawang density na. Okay? So, yung ating molarity, hindi mo sila pwede i-minus. Instead, what you can do is to get the moles muna. So, the MAVA is the molarity of your acid, the volume of your acid. Okay? So, mag. Okay? And then yung MTVT mo, this is your titrant. So, that's the mole of the base. So, isusubtract mo yung dinagdag mong base doon sa acid mo. Kasi nga, pre-equivalence ka na, no? Nagdadagdag ka na ng titrant base. Kaya, ganito yung equation. You subtract how much base you added from the acid that you have, and you divide it by the volume total. Why volume total? Remember, when we add two liquids, they get diluted. So, kaya may volume total sa baba. Okay? Kumbaga, dilution. No? Ayan. Okay? So, MAVA minus MTVT. That's the mole of the acid minus the mole of the base. Okay? Yung A dito, that is analyte. T is your titrant. Okay? Molarity analyte, volume analyte, minus molarity titrant, volume titrant. Ibibigay naman yan. Huwag kayo mag-worry. Now, let's go at the equivalence point. So, at the equivalence point, what do we have here? So, you don't have any acids na kasi lahat sila naging salt na. So, of the two compounds here, which will contribute to the pH of the solution? Okay, ako na sasagot siguro. The one that will contribute to the pH of the solution is the water. Okay? Wala ka ng acid eh. Wala ka namang excess base. So, yung water na yung magko-contribute sa pH ng solution. And always remember, for SASB, okay, strong acid, strong base titration, the pH at equivalence point is always 7. Always 7 yan. Why? Ano naging 7? It has something to do with the ion product of water. Okay? You know that in the ion product of water, you have your H plus and then OH, right? At equivalence point kasi equal. So, equal sila. So, magiging ano yan? H plus squared equals KW. So, meaning the amount of acid in an equivalence point is just the square root of KW. Okay, the square root of KW, or 1 times 10 raised to negative 7. So get the negative log, that will give you pH equal to 7. So ganun ha. So at equivalence point, pag tinanong kayo ano yung pH, ang sagot ay matic 7 without any calculation. Okay, 7 agad sagot dyan. Okay. And now at post-equivalence point, what do we have here? So at post-equivalence, you added too much titrant na. Nasobrahan ka na ng patak. So ibig sabihin, you have excess base. And the excess base will determine the pH of your solution. So siya yung magdidikta kung ano pH ng solution mo. And how would you determine the amount of excess base? Now basically, ito yung equation. So MTBT minus MABA na. Parang binaliktad lang. So this is the mole of the base added minus the mole of the acid. Okay? Bakit ganyan yung equation? O yung minus mole of the acid, ano yan? 'Di ba? Yung ibang base kasi ginamit mo sa acid eh. So isusubtract mo yan sa excess. Take note, yung kinukuha natin dito is excess. Kaya sinusubtract natin yung nagamit sa acid. Okay? So yun yung dahilan bakit ganyan yung equation na yan. We are getting the excess base, no, na nag-react sa acid. And of course, over the volume total, this is just for the dilution na that will happen. Kasi di ba nagdadagdag ka ng volume ng titrant, so nadidilute sila. So that's why we have to divide them by volume total. Okay? So ganun lang. And when you do that, yung MTVT minus MAVA, you will get the OH, which you can convert to POH, which you can then convert to pH. Okay? So, ano yan? Negative log ng OH, you will get the POH. And then 14 minus POH, you will get the pH. Okay? So, wag nyo kakalimutan yung mga pinagkukwento natin last time. Kasi gamit na gamit sila dito. Okay? So, yan. Umpisa pa lang to ha. Wala pa tayo sa mismong kalagitnaan ng topic natin. Marami pa yan. Okay? Pero just keep in mind yung mga ine-emphasize ko always. Okay? Keep in mind yung mga inuulit ko, especially dito sa species present, because that will actually help you know what equation should you use. Okay? Kasi ito yung magdidikta kung ano yung equation na gagamitin mo. Okay? So, ganun. So, ayun. For every stage, iba-iba yung equation natin. Okay? So, just to summarize, yung initial, whatever the concentration of the acid is, yun na yung dami ng H+. For the pre-equivalence point, ibig sabihin, nababawasan na yung acid mo, right? So, that can be calculated as MAVA minus MTVT divided by the total volume. At equivalence point, walang walang calculation, pH equals 7 na yan. Okay? For SASB. At post-equivalence naman, you have excess titrant. So, kunin mo yung concentration ng excess na titrant. Okay? So, that will be MT VT minus MAVA over V total. Okay? Ang daming equation. Ganon talaga. Ang daming sinasolve sa buhay. Isang version pa lang yan. Marami pa sa susunod na mga meetings natin. Don't worry, ito lang naman yung part na medyo, I'd say, grueling. Ito yung part na nakaka-stress talaga, yung titration. Kumbaga, ito kasi yung highlight ng Anachem for you. No? Pero pag ikaw BS Chem, 3 sem kang ganito. 3 sem na iba-ibang version ng titration yung i-discuss. So, basic pa lang ito. Pero, kayang-kaya nyo yan, of course. Okay. So, again, for each stages, iba-iba yung nangyayari. Iba-iba yung mga species present. Kaya, iba-iba yung equation. Okay. Let's try one problem. Alam na to ng aking lecture class. Kaya, pwede kayo mag-chill dito. Tapos mamaya, sagutan natin yung isang problem. Okay? Sa lecture kasi, in-skip ko yung isang problem. Kasi kulang sa oras. So, I want you to try this na. Sagutan natin muna as a whole. Then later, magbibigay ako ng item na pwede nyo sagutan. Okay? So, tignan nyo kung paano ako magsasagot. Okay? Basahin natin. Do the calculations needed to generate the hypothetical titration curve for the titration of 50 ml of 0.05 molar HCl with 0.1 molar sodium hydroxide. Sino yung analyte mo? Sino yung titrant? Ganito. Kapag given agad, no, I mean, siya yung nauna na given, siya yung analyte. Okay? So, sino yung nauna? Siya yung analyte. Sino ba yung nauna? Edi ito. May mga patterns kasi sa chemistry. Ako ilang taon na ako nagke-chem. Kaya, masasanay ka na lang. Okay? So, yan. Kung ano yung unang binanggit, yun yung iyong analyte. Kaya, siya yung A. Ibig sabihin yung susunod na binanggit, yun yung titrant. No? So, kumbaga alphabetical yung pagkaka-arrange. Okay? So, you have your analyte, your A, you have your titrant, the T. So, iba-iba yung mga A dyan, yan yung mga analyte, molarity times volume niya. Yung T dyan, yun yung titrant. Okay? So, yan. Okay? So, once na ma-identify mo na yung analyte titrant, check mo kung sila ay strong acid, strong base ba. HCl analyte is a strong acid. Sodium hydroxide titrant is a strong base. So yeah, SASB yung titration natin. Strong acid yung analyte. Strong base yung titrant. Okay? And then, what's next? Okay, sabi dito, these are the volume of the titrant added. And you are asked to get the pH. Okay. So, ganito. Gagawin natin is, diba, remember, kada iba-ibang volume ng titrant, iba-iba yung stages natin, diba? Dito nga yan, no? Kapag wala ka pang in-add na titrant, initial stage yon. Pero pag nag-add ka na, so it could be pre-equivalence or post. The question is, asan dyan yung pre-equivalence pati yung post? Diba? Kailangan may label yung volumes. Itong 0 ml, alam ko initial yan. Obvious naman eh. Okay, initial yan. Kasi wala ka pang in-add na titrant. How about itong 10, 25, 25.1? Ano sila? Anong stage kaya sila? So, ganito. Ang first thing na gagawin ninyo is to get for the equivalence volume or equivalence point volume. Okay. Alam ko, tawag ko dun last year, nang tinuro ko to, sabi ko sa mga bata ko, EP-vol. Equivalence point volume. Okay. So, paano mo makukuha yan? Just do some stoichiometry. Na? Okay. What do we know? At equivalence point, the mole of your analyte is equal to the mole of your titrant. Na? Plus yung mole ratio nila. Sorry, 1 mole titrant. Hindi ko na to naturo sa lect kanina. Hindi ko nabigay ito. Nawala sa isip ko. Pero anyway, monoprotic naman. So, kahit wala na yan. Okay. So, at equivalence point, ito yung ginagamit natin. Yung ginagamit natin sa lecture kanina. Doon sa chapter 4. Okay. So, we think that the moles are the same. Okay. And to get the moles, yun yung equation natin. Di ba? Tapos ano na gagawin natin ngayon? How do you get the moles? Kasi volume yung binigay eh. Di MAVA. How do you get the moles of titrant? Di MTBT din. Times this stoich factor. Bakit 1 to 1 lang yan? Kasi monoprotic tayo eh. Kaya 1 to 1 lang yung ratio nila. Okay? 1 divided by 1. Ano yung EP volume? Equivalence point volume ng titrant. So, hanapin mo yung VT. So, ganun yung gagawin niya. Hanapin niya yung VT. So, that will be MAVA over MT. Okay. So, this is the equation for you to get the volume of titrant. Okay. Hindi ko na sinama yung 1 to 1 ha. Kasi monoprotic naman ito eh. So, 1 to 1 talaga yung ratio nila. Let's solve for the volume of titrant at equivalence point or yung VT at equivalence point. VTEP pala tawag ko doon. Naalala ko na. Last year tawag ko sa kanya VTEP. Volume of titrant at equivalence point. VTEP. Okay. Yan. So, VTEP. Volume titrant at equivalence point. So, MAVA over MT. Molarity analyte. Ayun, 0.05. Volume analyte. Ayun, 50 ml. Molarity titrant. Ayun, 0.1. Ano yung VTEP natin? Ano yung volume of titrant at equivalence point? Can you calculate it? Pindot-pindot kayo sa calc niyo. What's the answer? What's the volume of titrant at equivalence point? Ano si VTEP? The volume of titrant at equivalence point is ilan? 25. Okay. By the way, yung mga ml, wag nyo na i-convert to liters. Okay? Hindi na kailangan. Okay. So, ang ating VTEP or the volume of titrant at equivalence point ay 25 ml. Important hanapin si VTEP. Pag di mo nahanap si VTEP, hindi mo alam kung anong stages yan. Okay? So, yan. We just realized that 25 ml is the VTEP. Okay? So, meaning, ito yung equivalence point. So, any volume less than that is the pre-equivalence, obviously. Wala ka pa sa 25 eh. So, pre-equivalence point pa lang yan. And any volume beyond that, 25 ml is the post. Okay? Ganun lang. Important po ba to gawin, sir? Yes. Kasi if you did not do this, malilito ka. Anong equation gagamitin mo dyan? Tandaan mo, for each stages, iba-iba yan, ha? So, it is very important for you to identify the correct stages first. Okay tayo doon. Pag may question, mag-chat lang kayo sa chat box, ha? Okay? Kasi Pag walang nagtatanong, I will assume na nasusundan. Okay? So, yun. But I hope na medyo clear naman ako sa side ninyo. Kasi I know medyo intimidated na kayo sa mga numbers, ang daming nakalagay. Pero wag kayo mahiya, na? Wag mahihiyang magtanong. Kung may right med ba nito, ganun. Okay? So, yan. Nahanap ko na yung volume of titrant at equivalence point, si BTEC. So, nalagyan ko na ng label yung stages. Speaking of bright med, bibili nga ako ng gamot mamaya. Kasi yesterday, ito rin yung reason ba't di ako nakapag-respond agad sa questions ng ilang students ko. Yesterday, Sunday, kita-kita kami ng mga college, graduate school friends. Tapos ako yung taga-ubos ng tower. Yung kasi role ko eh. Sinisimot yung tower. Ayan tuloy. Na-acid na ako. Okay. Pero kahit ganun, nakakapag-solve pa rin. Naalala ko dati nung college ako. Alam niyo naman yung buhay Maynila, no? Pag nagdo-dorm kayo, happy talaga doon. Minsan nagdadala pa ako ng assignment habang nagpa-party. Okay naman, tama naman yung solution ko. Minsan nga hindi ko masolve pag sober ako. Nasasolve ko siya pag may tama eh. Pero I'm not advising na gawin niya yan, ha? Mamaya kung ano-ano mo pindot niya sa canvas. Ganun lang talaga kasaya yung life noong face-to-face. So, sana na-experience nyo rin kahit paano. Okay. And basta just be a responsible student lang. Especially sa mga magdo-dorm, nako. Kali-kaliwa yung invitations dyan kapag naka-dorm ka. Alam nila malapit ka lang eh. Pero yeah, I hope you will experience that kind of fun sa college. Next year naman, I think, next academic year, I think, face-to-face na tayo. Ang dami kasi sinabi, yan na yung stages na labelan na natin sila kasi alam natin si BTEP na. So, and we know that for each stages, there will be a corresponding equation. Let's talk about the initial stage. So, at the initial stage, the amount of acid you have is whatever the molarity is. Ganun lang. So, whatever the molarity is, yun ay yung kanyang hydronium ion concentration. Yun. Ano ba yung molarity? Edi yun, 0.05 molar na. What's the pH? Ang CalQ. Open doon tayo sa CalQ. Okay. So, ano yan? Negative log of 0.05. Ayan ang pH mo. 1.30. By the way, 2 decimal places lang, ha? Baka mamaya kopyahin niyo lahat eh. Okay na kami sa 2 decimal places lang. Okay? So, the pH initially is 1.30. Ganun lang ka-simple. Okay? Next one. Pre-equivalence point. What do we know about pre-equivalence point? You added titrant, pero not enough. Okay? And for you to get the remaining acidity, okay, yung remaining concentration ng acid, ito yung equation natin. MAVA minus MTVT over V total. Okay? So, MAVA minus MTVT over V total. Sulat ko dito, ha? H plus MAVA MTVT over the volume total. MAVA, given na yan. Given na ba yan? Oo, given na yan. So, ito yon. This is the MA, this is the VA. Okay? So, given yan parate. So, you have 0.05 molar HCl times 50 ml. So, yung volume, wag nyo na i-convert sa liters. Okay? Magka-cancel out din yan mamaya. Okay. And then minus the titrant. Okay. So the molarity of your titrant is 0.1 times the volume of the titrant is 10 ml. So yan, lagay mo yan. Okay? So plug in lang talaga. Nasa baba baby mo. Hinahanap niya baby niya dito. Binaba ko kasi. Anyway. Ayan, how about the volume total? Okay? So for the volume total, all you have to do is to just add the volumes of your titrant and your analyte. Na? So bali, 50 plus 10 lang yan. Uma-agree yung cut ko. So 50 ml plus 10 ml lang yan. Okay? Calculate natin. Okay, so we have 0.05 times 50 minus 0.1 times 10 divided by 50 plus 10 to 60. So yun yung concentration. So 1 over 40 or 0.025 mole. Okay, so nakita nyo, nabawasan talaga yung yung acid. Kanina, 0.05 molar siya. Ngayon, 0.025 na lang. Okay? So, 0.025. Ayan yung molarity niya. And then, to get the pH, what we will do, negative log. Okay? So, negative log of that. 1.60. Okay. And now, equivalence. What's the pH at equivalence without calculating? Ano sagot? The pH at equivalence is automatically 7. Okay? Matic yan. So, it is 7 always. Okay? Bakit 7? Kasi ganito na lang isulat niya. Okay? So, it's just the square root of KW. Bakit ulit ganyan yung naging equation natin for the equivalence point? It has something to do with the species present. Okay? So, it has something to do with the species present. If you just have water and salt, the main source of the pH will be the water. And how do you calculate the pH of the water? You have to use the ion product. Okay? So, ito yung dahilan bakit naging ganyan. Okay? Ba't siya naging pH 7? Ganyan lang. Yun ang explanation. For the post-equivalence point, ano equation natin? We want to get the excess titrant. Okay? So, the equation is this one. MTVT minus MAVA over V total. So, we are getting the excess titrant. Okay? So, yun yung pinaka-purpose ng equation. And take note that the titrant is a base. Okay? Take note, ha? The titrant is a base. So, we are actually getting the OH concentration, not the H+. Okay? Kasi base yung titrant eh. Okay? OH yun ang kuha natin. Baka kasi mamaya isipin nyo ano pa rin yan. Baka isipin nyo na siya ay ano pa rin. H+. Okay? So, magpapalit lang sila ng position. Okay? Share ko lang. Nung college kami, hindi ganito yung turo sa amin. Kaya parang nahirapan ako sobra. Pero nung nag-review center ako, ganito yung turo. Sabi pala, ang dali pala na ito. Kasi dito, magpo-plug in ka lang na. Basta alam mo yung stage mo, alam mo yung equation, magpa-plug in ka lang talaga. Kaya yan. Ngayon, nagtuturo ako ng anak eh. Ito yung sinashare ko, yung nasa review center. Okay. So, MTVT minus MAVA. Okay, so molarity of titrant, ayun, 0.1. The volume of titrant, ito, 25.1. Oopsie, 25.1 minus MAVA, 0.05 times 50. Yung MAVA pa ulit-ulit lang siya, ha? Okay. Hindi yan nagbabago. Ang nagbabago lang yung titrant. The volume total also changes. No? So, the volume total is 50 ml analyte plus 25.1 ml titrant. Okay? So, yun yung volume total. Analyte plus the titrant. Okay? Pag may gusto kayo i-clarify, sabihin nyo lang sa chat box, ha? Huwag kayo mahiya. Unti-unti lang naman tayo dito. Okay, let's calculate the OH concentration. Okay, so parenthesis, 0.1 times 25.1. 0.05 times 50 divided by 50 plus 25.1. This is the OH concentration, 1.33 times 10 raised to negative 4. Okay, that's the molarity of your OH, 1.33 times 10 raised to negative 4. Question is, what's the pH? Kayo magsagot. If that's the concentration of OH, what is the pH? Sige. Tignan ko kung careful kayo sa details. Okay, sige. What's the pH? Okay. The answer is 10-12. Okay, 10-12 yung correct answer. Bakit na? Kasi kapag ni-negative log natin to, what we actually get is this is the POH. So ito kasi OH concentration. Okay. So this is the OH concentration. So if you get the negative log of this, that is POH. If you want to get pH, you have to subtract the POH from 14. So you get 10-12. Okay? So ayan, yun yung common din na. Don't worry, ganyan talaga yung common mistakes. Okay? But that's fine. At least we now know. Okay? Ayan, so there you have it. That's how we determine the pH per volume of titrant added. If you're going to if we're going to draw it, nagbubulol na ako. So if you're going to draw a titration curve, that's simple lang. On the x-axis, you have your volume of titrant. And in the vertical axis, you have your pH. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Tapos dito siguro, ito yung 5, 10, 15, 20, 25, 30. Okay? Tapos ipa-plot natin yung pH per volume of titrant na. So at pH, at 0 volume of titrant, pH is 1.3. Probably that point. At volume 10, the pH is 1.60. So it should be somewhere here. At 25, that's 7. Okay, so at 25, it is 7. And at 25.1, so konting urong lang, naging 10. Laki ng pinagbago, no? Like, isang patak lang. Ang laki ng pagbabago sa pH. Oops. Ay, nawala yung aking panulat. Yan. Ay, also, UAAP season na rin pala. No, kita-kits na lang sa, sa Araneta Coliseum pa rin ba? Hindi ko alam kung anong school yung uupuan ko doon. Nagtuturo ako dito sa Ateneo din. Kasi student ako sa Lasal. Iniisa-isa yung UAAP. Ganon yung goals. Isa-isahin yung schools. Ayun na. Yan na yung mga point. I-connect na lang natin. Okay. By the way, huwag nyo igaganon ha. Mali yan. Ang gagawin nyo, when you are near the inflection point, dun lang magiging sharp yung change. Okay? Yan. Something like that. Parang pa-S. Ganun. Pero syempre may curve na. So in your lecture, ito pinakita ko na to sa students ko kanina sa lecture. Ganito kasi yung prob set doon na. So I'll give you a problem, mas bahala na kayo gumawa niyan. Kumbaga gagawa ka ng titration curve, no? Yan. So as you can see, the pH will slowly rise until it becomes sharp. And again, sharp yung kanyang curve. Tawag natin dyan inflection point. And then, ayan, nag-plateau siya. Okay? Kaya kailangan pa letter S yung ating shape. Okay? So, it's not necessarily, hindi naman siya kailangan super ganda. Okay? That's how you do pH calculation for strong acid, strong base titration. Okay, now I will ask you, clear ba tayo dito? Kasi magpapasagot ako sa inyo ng isang item. Okay? So, hindi namin to sinagutan sa lecture kasi yun yung goal ng laboratory, kaya parehas yung topic para masagutan yung hindi masagutan sa lecture. Kasi limited yung time sa lec eh. So, that's how you get the pH, no? Same yung ating mga sagot na. Yeah. Try this one. So you have 10 ml of 0.1 molar HCl and you titrated it with 0.05 molar NaO, sodium hydroxide. So again, kung ano yung unang sinabi, yun yung analyte. And this one is your titrant, no? Kung ano yung unang sinabi, yan yung analyte. And sumunod, yun yung titrant. Just to give you the steps, hanapin nyo si VTEP. Find the volume of titrant at equivalence point using Stoic. Tapos, pangalawa, identify stages. Okay, so identify mo ng stage yan. And then, solve for the concentration, then pH. No? For either H plus or OH, then pH. Okay, so those are the steps. Okay, kaya ba ng powers? Kaya yan, no? Ayan, so sige. Try nyo sagutan to. I'll give you, let's say, ilang minutes kaya. So, maybe around 7 minutes, no? Okay. So, I'll go back, no? After 7 minutes. If you encounter some problems, send it in the chat box, okay? Pero bago ko kayo bigyan ng 7 minutes, paki-screenshot itong equations na to. Okay? Para alam mo yung ito-type nyo mamaya. Okay? So, take a screenshot of this slide and then answer the problem in 7 minutes. Tignan natin kung okay ba tayo. So, kung gusto nyo i-chat yung answers nyo, pwede namang ang chat nyo ay yung sequence na lang ng pH, no? Kunwari ito, 1, 2, 3, 4. I-chat nyo na lang yung sequence. Okay? So, ito lang naman yung gusto ko, yung pH. Okay? O, sige. I want you to try this. And then, I'll go back to you after 7 or 8 minutes. Okay? Sige. Balikan ko kayo, ha? Kung gusto nyo rin kumuha ng food na, sige lang, go. Feel free to eat. So, I'll be back after 8 minutes na lang. Ay, pag may problem, mag-chat kayo, ha? Sabihin nyo lang sa chat box. Sige. Balik ko sa previous slide. Okay. Just for an example. Okay. Babalik ko lang, ha. So, take a screenshot. Ganyan. So, take a screenshot na lang. And this will actually guide you in answering the question kanina. Okay? So, take a screenshot. 5, 4, 3, 2, 1. Okay. Babalik ko na dito, ha. Yan. Pag di nakuha, ito ulit. 1, 2, 3, 4, 5. Okay. So, yan. Okay. Kumusta? Sino yung tapos na? Press like button. Pag hindi pa, edi sad button. Sad talaga. I think hindi pa tapos na. Wala pa lang sad button dito. Okay, so, what you're answering, no? I hope you are. I will show you the solution. Okay. Sige. So, bali, if you are done, i-chat nyo na lang dito sa chat box. By sequence na lang. Kunwari, PH3, tapos 3.5, 4, ganun nyo na lang siya i-chat. Okay? So, medyo marami to. So, it will take me a while also to completely answer everything. Okay? But I will show you how. So, sige. So, while you are still answering, bigay ko yung answer doon. Sige. Hanapin ko si BTEP. Ang aking best friend na si BTEP. Okay? So, again, to get the volume of titrant at equivalence point, we assume that everything is equivalent. Okay? So, dapat ganito siya. Okay? So, the moles of analyte is equivalent with the moles of titrant. Okay? So, how to get moles? So, that's molarity times volume. Okay? So, MAVA, MT, VT is 1/1. Okay? Bakit 1/1? Kasi nga, it is monoprotic. Okay? Monoprotic kasi. Ay, what's next? To get the VT. Okay? So, let's solve for the VT. Si VTEP. Okay? That will be MAVA over MT. So, that will be 10 ml, 0.1 molar, and this is 0.05 molar. Calcu 10.1.0. Okay, so 20 ml is the VTEP. Who among you got this correctly? Sino yung nakakuha ng 20 ml as your VTEP? Okay, so si Christine, very good. How about the others? Kumusta sa iba? Okay, I hope you're still answering, ha? Ayan, si Lance. Okay, good. Sige. So, 20 ml is our VTEP. No? So, siya yung ating equivalence point. So, meaning, we can label the stages accordingly. No? So, initial, tapos itong mga to, ayan ay pre, EP. Ganyan na lang, nakatamad eh. Kasi ito ay mga post. Okay. Okay, so yan. So, initial, pre, equip, then post. Okay. So, kung tama yan, madali na lang. Okay. Sige. So, for the initial pH, basically, whatever the concentration of the acid is, yun na yun. Okay, yun na yung H plus niya. So, that will be 0.1 molar na. Okay, so what's the pH of a 0.1 molar? I think it's 1, if I'm not wrong. Yeah, tama. So, pH is 1. And then for the pre-equivalence point, the equation to be used will be H plus equals MAVA minus MTBT over P total. Okay, O yung MAVA, it's constant naman. So 10 ml times 0.1 molar. Tapos yung MTVT, that will be 0.05 times whatever the volume of the titrant is. Okay? So yung B total, that will be 10 ml plus the volume of titrant. Okay? So, tatlo yung sagot dyan. Ay, substitute ko na lang yung 1, 10, tapos 19.9. Okay? So, substitute ko. Type ko muna yung equation. Yan. Minus. Okay, for 1 ml, this is the concentration, 0.86. Okay, and the pH is just the negative log of that. The negative log of that. Okay, so 106. We got 106 for 1 ml. Nakuha din ba yan? Okay, and good. Okay, so that's 1.06. So 1.06. For 10 ml, I'll do the same. Ayun, gagawin ko na, ilan negative log ko na, ha? Para pag inequal sign ko, pH agad. Okay? Ganun ginagawa ko yung shortcut madalas, eh. Pero if you are still confused, pwede naman mag-long method kayo. Ako kasi mahilig ako sa shortcut. 10 ml naman now. So 10 ml, so 10 plus 10, okay. So ito yung pH, 1.60. Who got the same answer? pH is 1.60. Okay, and good. And very good, 1.60. And then for 19.9 ml, so ganito na lang gagawin ko. Kayo kung gusto nyo ganyan, shortcut, pwede nyo naman sundan. Ako mahilig lang talaga ako sa shortcut. Yan. And then for 19.9, the pH is 3.78. Who got that? Okay. 3.78. Who got that? Marami din. Okay, so yan, very good. That's great. So 3.78. At equivalence point, wag na magdalawang isip, 7. Yun na yan. Pag tinanong yung equation, sulat nyo na lang to. H plus equals square root of KW. Ganun lang. For the post-equivalence point, ito naman yung equation dito ay OH, na? So you have your OH equals MTVT minus MAVA divided by the V total. Okay? So yung MAVA, ulit-ulit lang yan. Same equation. MTVT, yung volume ng titrant lang yung nagbabago. Okay? So I will write 0.05 molar titrant times the volume titrant minus yung analyte. So yung analyte, the same lang naman. Okay? Times 10 ml. Volume total still the same na 10 ml plus volume of titrant. And again, do not forget, ito ay OH. So makuha nyo, pag ni-negative log nyo to is POH. So i-minus nyo pa siya sa 14. Okay? So I will do the shortcut in my calcu. Basically 14 minus the negative log. Okay? Kayo, kung nag-long method kayo, go lang. As long as we arrive with the same answer, that's good. 0.05 times 20.1 muna. If you wish to clarify something, let me know lang ha, in the chat box. It's open naman. Times 10. 10, close parenthesis. And plus 20.1. At pag pinindot ko equal sign, pH agad lalabas. Okay? Kasi ginawa ko 14 minus negative log na. Okay, so it's basically 14 minus the POH. Okay? So, this is the pH, 10.22. Who got this pH for 20.1 ml? Okay, so we have Shingle, Lance, Christine. Okay, yeah, very good. Okay, so 10.22. Ayan, since nasusundan nyo, di alam nyo na. Kayang-kaya na ang quiz dito. Pero April pa naman, huwag kayong mag-alala. Matagal-tagal pa. Okay, 25 ml. Palitan ko lang to. 25. Same as sa denominator. Yung iba kong student dati nakakalimutan yan sa denominator. So, huwag nyo kalimutan. That's 11.85. Who got the same answer? 11.85. Yun. Very good. 11.85. And then lastly, 30 ml. 30. Pati denominator, huwag kakalimutan. 30. Okay, so 12 point. Teka lang. Tama ba? 30. 10 plus 30. So ito sa akin, 12.09. 12.10 actually. Got 12.10. And siguro ano lang sa denominator. Okay. And so good. Pero okay naman. The rest of the answer is correct. So it's still good. Okay, ayan. Daming pinindot sa buhay. Ganyan yung mangyayari sa quiz. So, 'di ba? Kapag binasa mo kasi yung textbook, ang libro namin dati Skoog din eh. Nako, wala akong nagets. Wala akong nagets sa Skoog eh. Kaya iba yung ginagamit kong libro nung undergrad ako. Si Harris. And then upload ko siya sa lecture course card. Tignan nyo na lang sa lecture course card. Yung first learning material doon, chapter 1. Andun yung Skoog. Kung gusto nyo ba, yung Harris. Doon ko nakikita itong mga shortcuts din. Okay, so ganun lang. So that's how you do the iteration. If you're going to graph it, so it's easy. Madali lang. Hindi ko na i-graph pero it has to look like this. Parang ganyan. See? Okay, parang ganun dapat. Something like that. Okay, kapag ganun. Hindi ko na i-graph kaya na bahala dyan. Ganun lang, easy. Let's now proceed with the next one. Siguro hanggang dito na lang tayo, no? Sabi ko kasi maabot natin yung weak acid eh. Pero mukhang next meeting pa to, no? Just okay lang, huwag tayo magmadali. Kasi calculation to eh. Okay. Kailangan gets talaga. Kasi kung hindi na gets, nako, damay-damay yan. Okay. So yeah, so we're done with strong acid, strong base, no? So that's how you do it. Alamin mo lang stage, hanapin si BTEC, identify the stages, then once you have the stage, you have your equation, or ipa-plug in mo na lang yung numbers. That easy. Now, how about strong base, strong acid, no? Titration. O dito, baliktad naman. Yung ating titrant is the strong base, sorry. Ang ating analyte is the strong base, okay? And our titrant is the strong acid, no? Baliktad naman yung case ngayon, okay? So, strong base, analyte, strong acid, titrant. O, tapos ano ngayon? Ang ganap is medyo parehas lang yung calculation. Okay? So medyo parehas lang yung equations. Okay? Let me just point the key difference. The key difference here is that since OH yung given sa'yo, base kasi so you will begin with a very high pH, no? Okay? Compare yan sa acid kanina wherein you have a low pH, then eventually gaganon siya. For strong base, strong acid, the graph will flip because your analyte is a base. So, mataas talaga pH niyan. And then, upon adding your titrant, onti yung base, meaning bababa yung pH until it reaches the equivalence and the post-equivalence. Okay? So, the derivation of equation is similar with what we had earlier. Medyo parehas lang sa ginagawa natin kanina yung equation. Basically, it's just for initial, you have the base which contributes to the acidity, or that's the basicity pala, which contributes to the basicity. So, to get the pH, or whatever the concentration of the base is, yun yung OH niya. And then, from OH, what you have to do, convert it to POH, then eventually to pH. Okay, so ganun lang. And then, when you add your titrant, that's pre-equivalence point na. And then, ang gagawin mo, since your base is getting lesser, muonti na siya, then you have to deduct the amount of titrant added to your analyte, no? So yun, so that's MABA minus MTVT pa rin. However, the concentration that we are getting from this is the concentration of the base. We are just eliminating the amount of the titrant added, no? So this is mole base minus mole acid divided by the total volume. Okay? So, parang kanina lang, pero baliktad na sila. Okay? Then, at equivalence point, just like earlier in SASB, ano lang yan, 7 din. Okay. So, because the water is the major contributor for the pH, the pH here is always equal to 7. And at post-equivalence, parehas din siya with SASB kanina. Dito naman, we have an excess of titrant acid, no? So, yung excess acid naman. So, this is still MTVT minus MAVA over volume total. Okay? So, ganun lang siya. Let's try this one. Just to summarize. Okay? So, for the initial, the concentration of OH is whatever the concentration of the base is. No? Napindot. So whatever the concentration of the base is, yun yung OH mo. At pre-equivalence, nababawasan yung base. So, that's MAVA. Okay? So, MAVA MTVT over V total. And then at equivalence point, it's always 7. So that's H plus equals square root of KW. And at post-equivalence, you have excess acid. Okay, so your titrant now is the acid. So it's MTBT minus MAVA over V total. Okay. Pares lang din kanina. Ito lang yung nagkapalit, no? Yung OH, pati itong H plus. Kasi your analyte is a base. So, same lang, ha? If you want to take screenshot, please do so. Mamaya mag-answer din tayo ng isang question. Okay, so, try natin to. Calculate the pH during the titration of 50 ml of 0.05 molar sodium hydroxide with 0.1 molar HCl at 25 degrees Celsius after the addition of the following volumes of reagent. So, ang biggest question here is, what's the VTEP? Okay, can you calculate for the VTEP so that we will know which of them is the equivalence point? Okay, could you solve for the VTEP? Si VTEP, yun yung volume of titrant at equivalence point. Siya yung best friend natin today. What's the VTEP? Ano yung VTEP natin dito sa problem? Okay, so it's 25 na. Kaya nga sinakto ko na siya dun. Sinakto ko na dyan. So that's VTEP na. Okay, so this is the VTEP. I will no longer show the calculation, pero it's just MAVA over VMT na. Okay. So, yan yung ating equivalence point. Meaning ito ay pre-equivalence point, and this one would be post-equivalence point. Okay, so same lang ng pinagagawa natin earlier. Okay, so pre-equivalence point, you already added some titrant, okay, the acid titrant. So meaning to get the remaining OH, the equation to be used will be MAVA minus MTVT divided by V total. Okay, so MAVA, so ano yung MAVA natin? Okay, so MAVA is 0.05 molar sodium hydroxide times 50 ml minus MTVT. Okay, so the 0.1 molar times 24.5. Then 50 plus 24.5. Okay, again, kung ano yung unang sinabi, yun yung analyte, ha. Wag kakalimutan, analyte, yung unang sinabi, titrant ang susunod. Okay, so MAVA minus MTVT over the V total. So makukuha mo dyan is the POH, of course. So POH yan. What is this equation natin? 14 minus POH, okay? I don't know if ako lang, pero nafe-feel nyo ba yung ano, yung parang kahit anong tulog nyo, inaantok pa rin kayo? Kasi, di ba, alam ko naman puyat-puyat din kayo. Daling araw kayo nag-chat sa akin. Pero, di ba may parang ganun feeling? Like, kahit anong gawin mong tulog, still pagod ka pa rin. Naubusan na ako ng melatonin ba yun? Sa sleep well. Umiinom ako nun dati eh. And then I pause. Hindi pala siya okay din, no? If you just deliberately consume it, no? Medyo may problems din pala siyang i-impose. Because of course, yun? Na-burnout to siguro. So, probably. But I hope na maging okay tayo lahat. Mahalaga naman, wag muna tayo magkasakit na, you know. Okay. So, kaya nga ine-extend ko yung mga deadline, no? Para in case na burnout kayo, pwede naman magpahinga na. No big deal sa akin yan. Ako rin kasi ganun ako minsan. Okay. So, this is the equation I use. So, that's 14 minus POH. Kaya ganyan yan. Okay. Para pag pinindot ko equal sign, na yung nakalabas? POH. IPH na. Okay. Kasi if you just take the negative log of this is POH, no? Subtract mo pa siya sa 14. Okay. Equal sign, this is the pH. 10.83. Okay. So, mataas talaga yan kasi pre-equivalence point yan ng SBSA. And then, equivalence point, wag na magdalawang isip, ang sagot ay 7. Sana maraming ganyan sa quiz, no? Siyempre, di ako papayag nun. Pero may ganyang questions then, don't worry. So, yung pag sinerte kayo, matatapat sa yung question na yan, no? Sarap buhay. And then, next one, post-EP. So, the equation of post-equivalence point is that I have an excess acid here. So, that will be MT VT minus MAVA over V total, no? Okay, so titrant minus analyte. Now, in titrant natin, 0.1 molar times volume of titrant, which is 25.5. Minsan, di ko na nilalagay yung unit. Basta, gets mo na siya. For the analyte, 0.05 molar times 50 ml. Divided by the total volume, so you have 50 ml titrant, 50 ml analyte plus 25.5 titrant. Ito, pag ni-negative log mo to, pH na to. Okay, kasi H plus concentration na yan eh. Okay, so negative log of that thing. 0.1 times 25. By the way, kapag may question, mag-open lang kayo, ha? So, it's 3.18. Okay, so that's the pH already. Okay, 3.18. Ayan, very good. Okay, kung nasundan, may ipapagawa uli ako. And pag nasagutan natin yun, siguro we can call it a day na, no? Okay, so, any question about this one? Okay. Mag-iingat lang, ha? Kasi mamaya, kapag nagre-negative log kayo, baka isipin nyo pH yun o kaya POH. So, you have to be very careful. Okay? Tandaan nyo, nung nag-flip tayo, di ba kanina SASB, puro H plus yung nasa pre-equivalence. Ngayon, SBSA, OH na yung nasa pre-equivalence. So, you have to be very careful, especially when taking the negative log. Baka magkamali kayo ng malagay. May student ako na ganun dati. Ang quiz kasi natin dito, yung ito type mo yung answer. Ito type mo yung mismong pH value. Na nangyari sa kanya, napagbaliktad niya lahat. Sayang. Okay lang naman daw sa kanya. So, kasalanan niya daw, nakalimutan niya. And basta just be careful lang. Okay. So, ganun kasi quiz natin dito. Yung may boxes yung canvas, tas ito type mo yung answer. Pero again, August tuloy. April pa yan. Kaya nothing to worry. Okay? Ayan. I'll give you another 10 minutes ulit. I'll give you another 10 minutes to answer this problem. Okay? So calculate the pH during the titration of 25 ml of 0.025 molar sodium hydroxide, 0.05 molar HCl after the addition of the following volumes of reagent. Ayan. So you have your volume titrant, calculate the pH. Okay? So, bago kayo mag-answer niyan, take a screenshot of the following slides. This one. So that you will know what equation should you use. Kasi kapag mali ang equation, wala na. Okay? Okay, so take a screenshot of that one. Sorry, ito yung typo ko dito. Hindi ko pa rin siya na-edit pala. It should be SA kasi your titrant is a strong acid. And then take a screenshot of this one para mas malinis. Yung sulat ko kasi ganun eh. Ayan, so take a screenshot. Then after that, I'll give you 10 minutes, okay, to answer the next item. Okay, so yan. So just like what we did earlier, hanapin nyo si BTEP and then assign the stages and then be careful when getting the pH kasi baka mamaya POH yung makuha mo. Okay? Dun nadali yung isang student ko dati. Sayang naman. Pero bumawi siya nung sumunod na mga chapters. Okay? So yan, try to answer that again kung ano yung unang sinabi, yun yung analyte. Okay? So I'll be back by 12:53. Okay? So pag may concerns kayo, just let me know in the chat box. Okay? Nag-scroll lang ako sa Facebook. Okay, so let's check no, kung kumusta. Saan yung tapos na? Siguro most of you may answer na pero di lang confident na. That's fine. Okay, I'll show the solution naman later. Okay. So, this is a strong base, strong acid titration because the analyte is sodium hydroxide, so it's a strong base. And your titrant is HCl, which is a strong acid. Okay. If you're still not done answering, that's fine. Okay. But later on, I'll ask you if tama yung mga nakuha niyong mga pH values. Okay. So, just like what we're doing earlier, hanapin natin ang ating best friend na si VTEP. Okay. So, let's find for the VTEP. Okay, the volume of titrant at equivalence point. Okay. So again, the assumption is that the moles are equivalent. Okay, so 1 mole titrant, 1 mole analyte. Okay, so stoic natin yung kinuha na. Ito yung ginagamit natin sa lecture chapter 4. If you watch the asynchronous video. Okay, so ganyan lang yun. And then, how do you get the moles? So it's MAVA equals MTPT. So 1-to-1 lang yan kasi that is a monoprotic acid-base titration. So 1-to-1 lang. So kahit i-delete ko na, okay lang yan. So hanapin si VTEP. So it's MAVA over MT. What's the answer? Type nyo na lang yung answer in advance. MAVA. Okay, so this is your analyte. And this is your titrant. Okay. Okay, that's your titrant. Yeah. Okay, so 25 ml, 25 ml, 0.0250 molar, 0.05 molar. Okay. Ano sagot dito? Oops, ano nawala? So it's 25 times 0.025 divided by 0.05. Feeling ko 12.5. 12.5 nga. Last year, ito yung naaalala kong problem eh. So it's 12.5, correct. Okay. So ito yung VTEP natin. So siya yung equivalence point. Okay. So this is your initial. And this is your pre. Oopsie, magpass. And this is your post. Okay. Ayan. Okay. So good. Okay. Erase. For initial, whatever the concentration of your analyte is, that's the base concentration already. Okay. So whatever the concentration of your base here, yun na rin yung kanyang OH concentration. So that will be 0.0250 molar. Okay, 0.025. So pHi, negative log 14 minus negative log ng 0.025. Bakit may 14 minus something? Kasi nga, POH yung makukuha ko if I just take the negative log. So, I have to subtract it from 14 para siya ay maging pH. Okay? So, this is our initial pH, 12.39, sorry, 12.40. How among you got the same answer? 12.40. And good. How about the others? No? Kung hindi pa rin finish, okay lang. But I hope na you are doing well. Okay? So it's 12.40. Again, be careful kasi baka mamaya nakalimutan nyo i-subtract sa 14 yung POH. Okay, so you have your 12.40 there. At the pre-equivalence point, we are going to subtract the moles of the titrant added. Okay, so the equation here is MAVA minus MTVT over V total. Okay, so MAVA is still constant yan. So it's 25 times 0.025. Then for the MTVT, yung volume ng titrant yung nagbabago. So substitute ko na lang siya later. Okay. 0.005 molar HCl titrant times whatever volume of titrant is. And then for the V total, you just add 25 ml of the analyte plus the V titrant. And then take its negative log, then subtract it from 14, you will get the pH. Okay? Sige. Dito ko na lang i-plug in. So that's 25, 0.025 minus 0.05, 2.5 ml muna. Tama ba pinindot ko? 25, 0.025, 0.5, 2.5. Okay. So for upon addition of 2.5 ml of the titrant, the pH is now 12.26. So got the same answer, 12.26. Okay. So, ayan. So good. So 12.26. May concern kayo, let me know lang, ha? Okay. Ako pumipindot-pindot lang ako dito. Next one, 7.5. Okay, 7.5. Ay, sorry, mali. Okay, upon adding 7.5 ml titrant, I have a pH equal to 11.89. Okay. So, nilagay na ni Eric ko yung answer. So, check natin later. So, 11.89. Okay. Still the same answer with others? And good. Sige. And then we have 10 ml. 10 ml. So it's 11.52. Same then. 11.55 pala. So 11.55. 12, no? 12. It's 10.83. Okay. How about equivalence point? Wag na magdalawang isip. It is 7. Okay. So just write H plus equals square root of KW. And then for the post-equivalence, you have an excess amount of titrant. Okay, so the equation should be MT minus MTVT minus MAVA. Okay, so yun yung ating ganap. So excess tayo titrant, so meaning acid na yung ating nasosolve dito. So MTVT minus MAVA, okay, over V total. Okay, ayan. So molarity titrant, so it's still 0.05 molar times whatever the volume of titrant is minus MAVA. Okay, ano ba yung MAVA? 0.025 times 25 ml divided by the sum of the volume. So it's 25 ml plus VT. Wala na yung minus 14 ha, kasi H plus na yan eh. So, pH na agad yan pag ni-negative log mo. Okay, 12.6, tignan natin. 0.05. 12.6. 12.6, oopsie. Nagkamali ako ng type. 0.6. Okay, so 3.88, 12.6. Okay. Okay kayo dyan. 3.88 na. Tapos 12.9. Okay, so 12.9. Oops. 12.9, it's 3.28. Okay. Same answer. Yan, I'm good. So 3.29, 28, sorry. And then lastly, at 15 ml, 15, oops. ml, I have 2.51. Okay. Still the same answer with others. Okay. So yan, very good. Ang galing. Gets agad na. So good. Good work. Asan yung mouse ko? Nawala yung, ito pala. 2.51. Okay. So if you graph it, so i-graph niya siya. Ganito magiging itsura niyan. Ganyan. Then suddenly, whoop, gaganon. And then, pa-plateau. Okay. So yan. And in here, you have your VTEP. Okay. This is your initial, pre-equivalence, equivalence, and post-equivalence. Okay? So, ganun. So, that's how you do monoprotic acid-base titration. As you can see, as long as you know the stages, madali na lang. Okay? So, ganyan din mangyayari sa quiz and sa final exam. Okay? So, ang midterm exam natin, hindi ito kasama, no? Kaya, yung iba siguro nag-rest na lang. They will watch the video. Okay? Okay, so ganun lang. So that's how you do it. It's very simple as long as you know what stage are you in, what's the equation to be used. In case you forgot the equation to be used, you can refer back to the species present, no? Because that will tell you how to calculate the pH. Okay? So, next meeting, okay, so end na natin to. So next meeting, we are going to continue with the weak acid strong base titration. Ito, gagamit tayo ng Henderson Hasselbalch. Ayan, explain ko next meeting. And then, meron din tayong weak base strong acid. Ayan, gagamit tayo uli ng Henderson Hasselbalch. And buffers. No? Tapos on April 4, pupunta naman tayo dito sa last part ng topic natin. Naman yung buffer sa April 4 pa na. Bilis ng panahon, no? Like, malapit na yung finals. Okay. So, yan. So, I hope you learned something today, especially when it comes to titration, how to get the pH, no? So, we'll learn more next meeting, no? Para pagdating ng April, onti na lang yung ating habulin. Kasi, ganito yung weird sa sa second sem kasi. Ang weird is mayroon Holy Week. Ang walang pasok sa April sa Holy Week ay yung 14 to 16. Pero I know na yung iba sa inyo umuuwi agad ng province, right? So, mga 11 pa lang or minsan 9 pa lang. Oh, 9 is holiday pala, no? Day of Valor. So, siguro dito pa lang umuuwi na yung iba sa province. Tapos dire-diretso yan hanggang 16. Ako naman, may ano ako yan, magta-travel ako niyan. Okay? So, Holy Week. Akyat ako sa sa Baguio uli. I don't know. So, kung pumunta kayo doon, kita-kits na lang. Okay? So, yan. Most likely, baka mag-asynchronous na lang tayo nito. Okay? Sorry, ito pala yun. Yan. So, ito, synchronous yan to end chapter, dito baka may quiz tayo ng chapter 5. Although, I can extend the deadline siguro. Okay? And then, we'll have chapter 6, chapter 7, chapter 8, and then the final exam, completion week, then grades. Medyo fast-paced nga lang. Pero don't worry, after titration, mas madali na lang. Okay? Yung electrochem, madali lang yun to be honest. Okay? And then yung spectro, yung chromatography, super dali na lang nila lalo. Okay? So yun, anyway, at least you learned something, no? Hopefully. And I'll see you again next time, okay? So, next Thursday, kita ulit tayo na same time. Okay? So, bye-bye, ingat, and have your lunch if you have not eaten yet, okay? So, see you next time. Bye-bye. Ingat po parati. Okay, bye-bye.